Hi and welcome back to my channel Machine Learning with me. So today we are going to discuss multilinear regression. We are going to perform multilinear regression using Python on the insurance data. In my previous video, we have covered what is linear regression and we did perform simple linear regression on the salary data. If you didn't watch, uh, I would suggest you go and check it out. Uh, so if you're new to the channel, please do subscribe. So before getting started with linear regression model, we need to understand the data. So in order to understand the data, we are going to perform exploratory data analysis, and then we are going to do some data manipulations in the feature engineering, and then we are going to select the required attributes in order to predict the target variable. Then we'll go with model building and we'll wind up with validation. Try to import all the required Python packages. We are going to import sklearn, then we are going to import pandas, then matplotlib, numpy, and seaborn. Pandas and numpy is used to handle data frames and for the data manipulation, whereas matplotlib and seaborn, we are going to use them for plotting the bar graphs and scatter charts. Okay. So now let's try to read that our data file, which is insurance.csv, using pandas.readcsv. I want to print first few rows of my data set. So I'm printing the first few rows using the head method, which is in the pandas. So our data set consists of 7 attributes, namely age, sex, BMI, children, smoker, region, and charges. So our goal is to predict these charges using remaining attributes with a linear regression model. So before that, let's do some exploratory data analysis. We'll try to find if we do have any null values in our data set. And then we'll try to see what kind of relationship of categorical attributes and numerical attributes have with our uh, target variable charges using various visualizations. So first I'm going to see whether if I have any null values using is null.sum. So luckily we don't have any null values in our data set. If we do have any null values, let's suppose say our smoker value in our smoker attribute does have 80% of null values or missing values, then dropping that column would be the best option. If it's just 10 or 20% of null values, it's better to impute or fill with the mean or median or mode, uh, uh, with the best suitable method. We need to fill it, because if you are going to drop this data just because of 10% of missing values, the model is going to lose a lot of important data if that data is more valuable for predicting. Okay. So let's see the categorical attributes in our data set. What is categorical data? Categorical data is the statistical data comprising categorical variables of data that are converted into categories. For example, uh, let's take the region column. Okay, in the region we have four different values: southwest, southeast, northwest, northeast. So there are four different uh, categories. Okay, so this kind of data is called categorical data. We are going to see what kind of relationship does the categorical data has with our target variable charge. Okay, so in order to see the relationship, we are going to plot bar graphs for the categories. Okay, for each categories, let's see the first category, sex. From this bar graph, we can say that male insurance holders are paying more than female. In the second graph for the smoker, we can see that insurance holders who are smoking are again paying more than non-smokers. In the third graph, we can see again according to the location wise, it does have some kind of relationship with the charge. So similarly, we'll try to find out what kind of relationship does this numerical values have with our target value. So I'm going to collect all the numerical attributes similarly as I collected categorical values by using select data types by excluding the object. Then I'm going to plot scatter plot for each numerical attribute. So let's check our first attribute, age. From this graph, we can say that age does have some kind of positive linear relationship with the charge. Then we can say from this graph, we don't really understand what kind of relationship does BMI has with uh, uh, charge. So we are going to pass on to next, that is children. From this graph, we can clearly see that more the dependencies, less the insurance holder is paying. So but here we can say there is only five values, so I don't want to consider this one as numerical data, but rather I want to move children attribute to categorical value, because we can sub clearly we can see we can subdivide the data into five different groups. So I don't want to consider this into the numerical value. Okay. Distribution of data. Here in distribution of data, we are checking whether or not our input data is symmetrically distributed, because linear regression model assumes that the input data is symmetrically distributed. If it is not symmetrically distributed, our model does not perform well in order to predict the target variable. So we can check for the distributions whether it's symmetrical or not using dist plot. Okay, here we can see that our BMI data is symmetrical and it's well organized. Okay, if it is not well organized or it's not symmetrical, we need to scale it down using few techniques such as log or min max scalar, standard scalar. There are many other methods to scale it down. I am going to make another video. I am going to explain all these methods in order to handle the distribution. For this video, I'm going to make it simple. Next, let's check for the outliers. How do we check for the outliers? Box plot is one of the best visualization tool in order to check for outliers. Now let's check outliers for the numerical values. Age doesn't have any outliers. BMI does have a few outliers, if you could see here, right? Children doesn't have any outliers. Okay, now that we have checked for outliers and distributions, now it's time to do the feature engineering. Okay, so in feature engineering, we'll try to do label encoding for categorical data. That's nothing but we are going to convert all these categorical values to numerical values. Then we can also do feature scaling, such as normalizing the data. We have seen that there are too many outliers, right? We can reduce the outliers. We can, if the data is not symmetrical, we can make it symmetrical using min max scalar and all. But I'm not going to do this one in this video. Again, I'm just giving you a heads up that I'm trying to make this video as simple as possible. In this video, we'll just try to go with label encoding for categorical data. So first I'll try to copy the dataset into a dummy variable. Then if the sex value is male, I'm going to give it 1, or else if it's female, I'm going to give it 0. The similar technique I'm going to apply it for the smoker. And in the region we have 4 values, so I'm going to enumerate it using the enumerate function. I'm going to get all the 4 region categories, and then I'm going to name it as 0, 1, 2, 3. Okay, here you can see it. For using this code, we have label encoded the categorical values to numerical values. We can also check what are the values for region we have after conversion. Okay, let's print the first few columns after performing label encoder. You can see all the categorical values have been converted here to numerical values, right? Now let's start feature selection. Feature selection. Before doing feature selection, we need to understand the importance of feature selection. In order to improve the model performance to predict the target variable, we need to select only the features which have high relationship with the charges. Okay, we should never push all these columns at a time in order to predict charges. Okay, model may overfit or underfit. By end, model will fail to predict the values. So how do you predict the best attribute from all this? How do you choose the columns, the best columns which are suitable for charges? For that, here we are going to do chi-square, and also later we'll do correlation. Chi-square, we are using chi-square if the input data is categorical and output is continuous. Okay, so first we'll try to see the relationship from the categorical and continuous using chi-square test. Then we'll try to select only few attributes from categorical. Okay, then again we'll perform correlation with continuous and continuous, and we'll pick few attributes from continuous. Now first I am trying to take all the categorical data from my data set. Then I am trying to add children column into the data set, because I previously I did explain you we have 5 different columns. So I don't want to take the children or the dependent attribute into the numerical, but instead I want to push it into categorical. So I'm trying to push it into categorical. We can see the few rows of our data set. Now let's perform chi-square test. Now here the chi-square test gives you f-score and p-value. Okay, higher the f-score, better the relationship with the target variable. So out of these 4, I am going to choose any 3 which have higher f-score. Okay, so I am going to choose smoker, region and children out of 4 categorical values. So we can conclude that using chi-square test for categorical variables, out of 4 categorical variables, we can only choose 3 because of high f-score and p-value. Okay, now it's time to see for numerical values. Okay, here is my numerical value including charges. Now I am trying to see the correlation matrix between them. If you see, age and charges have high correlation compared to BMI. Okay, don't see for charges and charges because it's always 1. The diagonal values in the correlation matrix is always high. So I'm going to consider only age. Now I have got age, smoker, children, region and charges has my best attributes to predict my linear regression model. Okay, now this is my final data set. Now I am going to train and test from this data set. Now it's a final stage. Let's try building a model and validating it. So from our final data set, we are going to take all the input variables into my X and the target variable into Y. Using train test split, which is from model selection, which is in sklearn, this train test split automatically pushes your X and Y values into xtrain and test, xtrain, xtest and ytest, depending upon how much training size and testing size you want to give. Here I am giving my testing size as 0.3. I have created the linear regression model here and I try to fit the data xtrain and ytrain. Now after fitting it, the value of xtest, okay, I'm passing the variable xtest to predict, and now I'm storing the predicted values in this variable. Now it's time to validate the model using r square metric. Okay, so I'm passing y test value and the predicted values to my r square. Now I have got around like 0.72. This is our model success rate. We can convert it into percentage, and we can say our model success rate is 72%. Now let's visualize, or let's see the actual values and predicted values in the form of data frame. Okay, if you see this value, the actual value over here for id 366 is, mm, let's say it's around like 13,430, but our model has predicted as 14,740. It's so close. It may be different, but it's so close. Okay, now this success rate does explain, right? We are seeing the results over here. Now we can also improve the model performance by passing many hyper parameters, that is called as hyperparameter tuning. We'll do discuss all this advanced topic in coming videos. So if you did like this, do subscribe, like and share.